everyone, I am Yashoda from LNBDI Japanese IT University. So, as I said in my last video, I'm going to talk about algorithms today. More specifically, I'm going to talk about bubblesort algorithm, which is a sorting algorithm. Let's dive in. Suppose you have a number array, but it's unsorted. What we're doing is comparing each number with its next number. If the next number is bigger than the current number, we swap the numbers. If not, we can leave the number as it is. So, we compare the first two numbers, and 5 is greater than 2, so we need to swap the numbers. There you go. The numbers are being swapped. Then we go to the next two numbers. See, 5 is less than 6, so nothing is wrong with that. Since the numbers are in the right places, no swapping is needed. Then we compare the next two numbers. 6 less than 8, so no swapping here as well. And then we go to the next two numbers. 8, however, is greater than 4. So, the swapping is needed in here. Therefore, we are swapping the two numbers. Just like that. Now, you see that we have completed one iteration in the array. But you can see that there are unsorted elements in the middle of the array. See? However, we can notice that the largest element in the array is now in its right place. So, what we are doing is we are doing this process again and again to the rest of the elements. This should swap. There you go. We completed another iteration of the array, and now the next largest element is also in its right place. So we repeat. We repeat again and again until this array is fully sorted. There you go. Again, we completed another iteration of the array. And now, the third largest element is also in its right place. And also, you can see now the array is fully sorted. So, let's now see how to implement this bubble sort algorithm using Java. As you already know, the process is two consecutive numbers in the array is compared, and if the current number is bigger than the next number, two numbers are swapped. This swapping process is repeated until we reach the end of the array. However, as you saw in the previous example, the array might not be sorted in the first try. Therefore, we need to reiterate through the array again and again and do the swapping process until the array is fully sorted. For this, we need two for loops with one for loop nested within the other for loop. This is the outer loop and this is the inner loop. The outer loop will control the number of passes throughout the array, and the inner loop will control the iterations throughout one pass in the outer loop and thereby control the swapping process. Now, if we focus on the conditions in the for loops, you will see that in the outer loop the condition is I less than n minus 1, and in the inner loop the condition is j less than n minus I minus 1. This means the number of passes throughout the array will be the same as the length of the array minus 1. But why is it n minus 1 instead of n the array length? You see, after each iteration through the array, the largest element of the array will be moved to the right place. Therefore, it will be a waste of time to compare the sorted elements again and again in the iteration process, which is why we remove the last element by placing the condition n-1 in the for loop. Same goes for the inner loop as well. See? Modifying the condition like this will optimize the sorting process by making the implementation efficient. After we locate which element to compare with the help of loops, we do the comparison using this if condition. So if the current element, which is the jth element in this case, is greater than the next element, or j plus 1 in this case, then the two elements are swapped. For this, we get the help of a separate variable called swap. And just like that, this code will run until the array, the given input, is fully sorted. So now let me test this class. This is code using the main method. So I have an array here, array called A, and it is an unsorted array. So my class is bubblesort, and I have made an object called B using this bubblesort class, and through the object I have implemented the method called bubblesort here. See, the method name is bubblesort, and to print the array, for the purpose of printing the array, I have this small method called print arr. So I have first implemented the bubblesort method using the object B, and printed the sorted array using print arr method. So if I run this code now, you will see that the array is now fully sorted. And that's how we do the implementation of this bubblesort algorithm using Java. So that is all about bubblesort. See you in my next video. Bye.